Earth science time.
You need to get a picture.
Yeah. I still have a title. We're going to talk about today evidence. Let's start with that. That's a good title. Evidence for ancient time. Boy, this is going well. Yeah. Evidence for ancient time. That's actually fine. That's a fine title. That's what we're going to call it. I wish I had poured it out of my mouth quicker so it didn't seem like I didn't know what I was talking about. Okay, we're going to start this. I'm going to use, this first part I'm going to use this marker, and then we're going to switch. Remind me I said that so that we can tell which one's better. That's called science. Okay.
You're supposed to say leave your comments which marker is better.
No. I have the comments turned off, so that would be rude, wouldn't it? Follow, like, and comment. Don't comment. Don't like it. Don't follow, because it's embarrassing to me. Okay. So the first thing we're going to talk about here, what are some physical pieces of evidence that we have for geologic time? Okay, thanks. Rocks. Let's put this. Physical evidence. Like stuff we can touch that tell us about geologic time. There is more than this, but primarily rock and fossil. Rocks and fossils. Those are the things that we can touch that can help us learn about geologic time. How though? Like how can a dumb old rock that you could just chuck in your neighbor's window be used instead for geologic time? Be careful though, because you don't mean that. You mean something different that people confuse with that. What were you going to say? Was it the same thing?
Because you can use it to date it.
Yeah. What do we call that kind of dating where we can tell its actual age?
Absolute.
Yeah, okay. So we can use something called absolute age dating. And we're going to differentiate that from what other concept?
Theoretical.
No. That's a good guess, but you're wrong. You should know this. Didn't you guys do your vocabulary?
Yeah.
What's the other kind of dating that we do?
Like you go to McDonald's?
Shut up, please. No, don't say that. We're going to talk about that in a second. Relative age dating. The joke I made, this is a great joke. Don't put your comments about this. The joke I made when I was talking about this a week ago with the 8th graders is I said, you know when you go to your family reunion there's that cute girl? No, that's silly. That's silly. That's a silly joke. That's a silly joke.
That's kind of gross.
That's pretty gross. But relative age dating, we have these two different concepts of dating. Why is it important to date for geologic time? The verb we're talking about here, to date, means not to take the girl to McDonald's, Levi. That's what you had said. It means instead, that's a sad date. Instead it means to learn the date of, right? To learn the how old this thing is effectively, right? To learn how old something is.
Just say find its birth.
Rewind it one more second. Why is it important that why do we have to use this dumb stuff this is cool stuff. Why don't you use this cool stuff to tell the ages of things?
That's all we have.
Because that's all we have, right? Because we can't.
It's destroyed, people died.
Exactly. We can't go back in time. Sometimes it seems like it'd be great if we could, but you'd wreck everything. You can't go back in time, and so all we can use is the stuff we have now to tell us about how the ancient past was. And these are the two physical pieces of evidence, and we do these two things with them. So absolute age dating is when we're telling what?
The absolute.
Very good. Let's rephrase it in words that aren't part of the...
Date we do know for sure,
No, okay, good. And don't think that. Don't think what that girl just thought. So we sometimes, because it says absolute age, that makes us think, oh, this is really precise and accurate. That's not the case. These two things, as opposed to one another, mean that this is telling us a numerical age. What's numerical mean? Related to numbers. Numerical age, usually in years, or mega-ana, or giga-ana, right? We use all those things. Whereas relative age dating is just telling us what?
Would that be in the...
Like a long time.
in this eon?
No,
Relative
those are still
to
absolute.
this.
Okay, which means what?
So and during the Precambrian?
Yep, there we go. No. Yes, Dally, you're right. Tyler, you're not. Because what we're doing is comparing ages of two evidence. We'll put evidences. Comparing ages. I don't know. This feels like there should be a different plural for evidence. There's not. Evidences. Comparing ages, we could say two pieces of evidence, but I'm going to say evidence is because you can, okay, if that's more satisfactory for your note keeping, you can put that. But so in absolute age dating, we're telling the actual age in years of something. If I were to say, oh, I know this one, Natalie is 17 years old, it was her birthday. That's a numerical age, that's her absolute age. We could, listen, it's her, whether we say Natalie is 17 years old, or if we say Natalie is 2 decades old, or if we say Natalie is 17 years and 4 days old, right? It doesn't matter how precise we are, it's all numerical ages, right? Even if we say Natalie's about 100 years old, even if we're wrong, it's still an absolute age dating, right? It's because it's got a number in it. Okay, so listen to me, and maybe write this down. Absolute age dating doesn't mean we know it for sure. It doesn't mean absolute in that we're 100% sure that's what it means. Cross that out of your brain, put it in your notes that that's not what it means. It doesn't mean we know it for sure. That's going to come up on your test because that's a very common misconception. Numerical age doesn't mean it's accurate. It doesn't mean it's precise. It just means it uses numbers, even if they're approximate. So Natalie Berry is 17 years old, right? That's a numerical age. That's an absolute age. Natalie is older than, I don't know, Skylar? Question mark, is that true?
No.
I'm older than.
Good try though.
You're older than who, Dally? Okay. Natalie is older than Dally. That's comparing two things. That's a relative age, right? So into the B is 17 years old. That's absolute. Natalie Berry is older than Dally. That's relative age dating, okay? So how do we use this for this? You've got to find out.
You compare them.
Yeah, so for this one we compare them.
Yeah,
What
but
this
like
means...
a bunch of comparisons, you could like put them in order.
Right, exactly. So what this means is that even if we only know Natalie's age and how it relates to everyone else's age, we can still put everyone in order of ascending age, even though we only know the actual age of one. Do you see why that might be important for rocks and fossils? Because we can't date, write this down in your notebook. Stop tearing apart your breakfast and write this down in your notebook. We can't absolute date everything. We, the scientists, can't absolute age date. What part of speech is the word date being used as in this sentence?
Is it like an adjective?
No, it's not an adjective. Thank you for trying.
It's a verb.
It's a verb. We can't absolute age date everything. But we don't have to, because we only have to, if we absolute age date something, and we know the ages of other things relative to it, we are successful. We've put them in order, and that's what our goal is to do, is to put them in order, according to this geologic timescale, right? So you have a geologic timescale. Did everyone bring the geologic timescale?
No.
Yes, you did, you little fibber. Take out your geologic timescale. What's the largest, let me say, what's the largest division of geologic time?
The palette.
Nope. You're answering my first question. What's the largest division? No, not the longest actual division. What do we call the...
Oh, the Precambrian.
What's-
Eons?
Eons. So geologic time is first divided into eons, which are larger than... They are larger than equals, but the next one is...
Epochs.
No.
Eras.
Eras. And those are divided into...
Periods.
And those are divided into...
Epochs.
And those are divided into...
Ages.
Good. And how long is an eon?
Just depends.
Exactly. Okay, it's a trick question. It just depends. There's no set age. There's no unit conversion from eon to years or eon to gigaon. These are all different amounts of time. Right? These are all different amounts of time. We just divide them in this way. What does form? If they're not all a certain amount of time, how do we know when one ends and one begins?
Like
Massive
events.
Yeah. Usually we look in the rock record or the fossil record to find mass extinctions, massive earth changes, things like that. Eons are the largest. What are the eons of Earth's history?
The Precambrian.
Precambrian's kind of a loose term. We don't really, that's not a eon or period or era. Yep, the Hadean. The first is the Hadean. The Archean. I'm gonna start these from just like your geologic timescale and all geologic timescales I've seen. The oldest should be on the bottom. We're gonna talk about that in a second. Hadean, Archean, Proterozoic. You remember the title of the other ones? All of those together are called the Phanerozoic. And in order to not confuse us, I'm going to put old down here. Right? The oldest one is on the bottom. So the eons of Earth's history, from oldest to most recent are Hadean, Archean, Proterozoic, Phanerozoic. We talk about what those words mean. Hadean means like hell. Archean means ancient. Proterozoic means kind of pre-life. It's like proto-life, like I don't know, an early life. Phanerozoic means whole life. Within these eons, we're going to talk about the eras of the Phanerozoic eon. Once again, they'll be from oldest to most recent. What are the eras of the Phanerozoic eon?
I can't read that.
Paleozoic? That should be pretty large. Paleozoic is one of the largest words on there. Mesozoic. Remember, your scale that I gave you is divided differently for these three eras, and then Cenozoic. Is everyone on board with this? Is everyone at least telling where we got these things from? Yeah? Okay, and then all of these are divided into periods. What's the earliest period of the Paleozoic era? Yep. Some people say Cambrian, some people say Cambrian. The British, I think, say Cambrian. I don't know. It depends on how fancy you want to be. The British. What comes after that?
I don't know how to say that.
Yeah, you do.
Is it Ordovician?
It isn't. It's Ordovician. Ordovician. This is getting bad handwriting. Ordovician, then Silurian. Named after Wales. The Latin word for Wales was Siluria. After that, I'm going to write it. Devonian, named after Devonshire in England. And then we have the Carboniferous, which we talked about is divided into the Pennsylvanian and Mississippian. Carboniferous. What do you think is the root word of that?
Carbon.
Carbon. Yep. Carboniferous. Next. Permian. Then, are you all following along? You're seeing this? Then what's after the Permian? Triassic. And that starts the Mesozoic, right? Triassic. Uh-oh, I'm going to run out of room. Triassic, then Jurassic, then Levi, you know how to say that word. Cretaceous. I'm going to have to erase these things that I wrote earlier because I ran out of room. This was poorly planned. Ooh, this erases nicely though. I think we figured out our winner. Cretaceous, and then there are two periods within the Cenozoic. They are, look on your little thingy. Well, yeah, so I don't know.
Oh, the tertiary?
We could say, yeah, the old style was tertiary, quaternary. The very old way of dividing these was called, I assume, primary, secondary, tertiary, which means third, quaternary, which means fourth, right? Which is true, but now we know that those two are there's a better way to divide it. So what we really usually do is Paleogene, which means old, and Neogene, which means new. And sometimes the quaternary is still added on top. It depends. And it differs depending on what kind of fossils you're talking about. I know that mammalian paleontologists, people who study mammals have only been around the very first mammals were in the Cretaceous. So mammalian paleontologists don't use the bottom just because they didn't exist. So they would often talk about tertiary or quaternary, just because that's the way it's done. And in fact, they mostly talk about ages and epochs. But other paleontologists that talk about bacteria, for instance, need to talk about this whole time and even down to the Archean. So we use numerical dating to tell the age of one specific fossil or rock, and then based on the principles of relative age dating that we're going to talk about in a second, we can learn the other ages of the other rocks, even if we can't date them specifically. Okay?
Okay.
Okay, yeah, that's exactly what I wanted to say. Everyone say it.
Okay.
Yeah, Tyler was still the most enthusiastic. Uniformitarianism, write it down. Have you ever spelled uniform? Write it. Uniform, and then write the I, which is the letter I.
Switch markers.
I'm going to switch markers. Thank you for reminding me. Let's see how nice this baby erases, though. I'm going to use one of these dumpy erasers. Oh, man. I don't know.
Terrible.
That's not, I wouldn't say it's terrible, but it's not. I think it helps if I do it this direction. That's interesting. You know how when you're tearing up the newspaper, I don't know, that's a weird way to start a sentence. You know how when you're tearing up the newspaper, if you tear it one way, it's nice, and if you tear it the other way, it's not nice? Do you know how this
We don't tear
is our, the bells ringing? No, I do a lot.
Why?
Let's not get into it. I think it's the same way up here, where if I erase left to right, it looks nice.
Wait,
I think
try
that's-
going up and down again.
It's still nice. I don't know. Maybe I'm just stupid.
Why do you revoke your newspapers?
Uh-oh. I erased my dang title.
Oh, good job.
Well,
Now you gotta rewrite it with the other one.
was I using the expo one?
Yes.
Yes, okay. I'm going to use Artelius.
That sounds like a fancy.
Evidence for, pretend it still says what it used to say, I don't even remember.
Ancient times.
Thank you. Evidence for ancient time. Uniformitarianism. Uniformitarianism. What? Uniformitarianism. This was a vocab word. Tell me what it means.
Can I write it down first?
Someone should already know. The point of your vocab is so that you know, not that you cram.
Nope, that's the wrong
I
one.
don't think so.
That's,
Is it like the uniform of...
Okay, that's the root word.
okay, which states that geologic process occurring today.
Yeah, exactly right. Purple Shirt had said that the geologic processes that are occurring today, it's a beautiful shirt, that are occurring today have occurred for how long? Since last week?
Or like, since the beginning of
Since the
Earth.
beginning of Earth. Since even when we extend this to exogeology, when we talk about other planets or moons of planets, these processes that apply now apply everywhere in the solar system where the conditions are met for those to occur.
Like Mars?
There's no difference, uniformitarianism says, between the delta at the mouth of the Mississippi River, which we talked about deltas a little bit, and the delta that has formed at the bottom of my driveway because it has snowed so much. Do you see what I mean? It's the exact same thing. The processes that occur here and now have always occurred here, God bless you, and everywhere else. Uniformitarianism. Why is it called uniformitarianism? What's uniform mean?
Same.
The same. If you got, have you ever been to McDonald's on a date perhaps? What do those boys wear that work there?
Uniform.
Uniforms. Why do they do that? So they don't show up in their Thrasher shirts. That's exactly, they don't want people to show up in their Cookie Monster jammy pants and their Thrasher shirts with their hair all undone. So they give them a uniform and they make them wear that way. Uniform means the same. They have to wear a uniform.
I think that they just have to wear a McDonald's shirt.
Yeah, that's a uniform.
Yeah, but they all
Uniform
look
means the same. Oh, they have many different
Yeah.
McDonald's shirts they can wear.
You can get a cutoff, you can get a crop top.
Crop top. They get a little halter top. This is not where I wanted to be.
You guys got a big old guy in a crop top pushing the burgers back.
Now I have to.
Imagine
Okay.
the boss man.
Okay, shh. Okay, that's enough. Okay, so uniformitarianism says that the processes that are occurring today have been occurring since Earth began. And that's important because with that, this is what my geology professor at college called trading location for time. Okay, why would we want to, as he says, trade location for time? What can we already discuss we cannot do to learn about Earth's past?
Go back.
We can't go back in time. So what we do when we want to learn about Earth's past in location X
We travel.
is we find some other location where that same thing that used to happen in location X is occurring, and we study it there, right? So here in this area, we know that the sandhills. You know the sandhills? The sandhills, evidence suggests, used to be rolling sand desert, like the Sahara Desert. So if we want to learn about that, we can't go back in time and be like, let's just go find out what the sandhills were like 50,000 years ago.
So we go to Africa.
So we go to the Sahara and learn about what's doing there now, and that helps us, right? Because all the processes that have been occurring since Earth's beginning are still happening now somewhere, right?
Just without the bathroom.
If we want to go on a field trip to see the Mississippi Delta, we don't have to. We can just go to my driveway, guys. I got a Delta there because it snowed so much. But it's better.
Fun.
No, we don't want to go to the.
Yes.
No, you want cheese on that? Okay. Next.
Well, she's
That's what I associate with Mississippi is someone in a diner saying you want cheese on that.
What?
We use the principles then of, yeah, we're throwing people under the bus all day long. Relative
Why'd you go to cursive?
age dating. This is italics now. Relative age dating. There are some principles of relative age dating that we use. to determine how things line up once we have the age of one of them. We don't even have to have the age of one of them. The most basic principle of relative age dating is what? You already know it. You should already know it.
Is it with rocks?
It's with rocks.
If it's
Is it
not
cooling?
turned over, the oldest is at the bottom?
We're going to write it fancy first. In
Okay.
an unoverturned, I hyphenated that. It shouldn't be hyphenated, but I hyphenated it for your benefit. In an unoverturned sequence of rocks, what's the rest? You already know the rest.
The
The oldest is on the bottom.
The oldest are on the bottom. In an unoverturned sequence of rocks, the oldest are on the bottom. Which part of that sentence do you think is like a qualifier that just we have to say to make it so it's always true?
Unoverturned.
Yeah, unoverturned. Almost always, 99% of the time, the oldest rocks are on the bottom. The reason we add this part to the beginning is so that it's always right? Because can you imagine some rocks do get overturned, and then the oldest rocks ain't on the bottom. So we have to make sure to say that at the beginning.
And that ain't
What
right.
about, okay, so in an unoverturned sequence of laundry on Levi's bedroom floor, where are the oldest nasty, crusty socks? On the bottom. On the bottom, right? In an unoverturned sequence of disgusting dishes in a nasty kitchen, where are the oldest nasty dishes? On the bottom, right? If you're working at the diner and you gotta throw in the lasagna plates, the oldest, crustiest lasagna plates are on the bottom. And then when you wash them 3 weeks later, you will find those are the highly crustiest. This is the simplest. This is the simplest but the most important of the relative age dating principles. We sometimes call these, let's back up a second, we sometimes call these Steno's principles, so let's write that down real quick. The man's name is Steno. It's named after Nicholas Steno, either Swiss or Swedish, I can never remember, from the 1500s, I believe. Steno's principles. I gave up on my fancy font though. Principles. Steno's principles.
That's what these all are called?
All these principles of relative age dating are called Steno's principles. Should have said that first. This was, and the name for this boy is called the law of. No.
Unturned.
You know it is. It's in your vocab.
Lava rocks. Lava rocks.
No, you're don't stop.
Principle of inclusion.
No, it's earlier than that.
The principle.
No, it's not earlier than that. Yeah, it is earlier than that. Give us your letter check.
Cross cutting.
Nope, try again. One more.
Super.
Superposition. What's super mean?
Right.
I spelled it wrong. Yeah, okay, very good. So super means great, but it also means, in science usually, super means above. So superposition, the rocks that are above other rocks. In an unoverturned sequence of rocks, the oldest rocks are on the bottom, right? In an unoverturned sequence of lasagna, the oldest slab of lasagna is on the bottom. Doesn't even make sense, right? If you're trying to make a lasagna and you're like, ooh, I gotta make sure to put that top layer down first. That doesn't make sense. You have to put the bottom layer down
Yeah,
first,
but
right?
they're not the same box, aren't they technically all made at the same time?
No, I don't mean for the. I mean when you're making lasagna, like which noodles you got to put down first. Okay, the next one we're going to talk about is original horizontality. So write that one down. Original, spelled the normal way. Horizontality. Oops, do spell that right though. I don't like some people. Horizontality. Can you guess what this is going to be about? Just from the words.
Things that are originally sideways.
Yeah, so when you say sideways, you mean like this, like the word
Horizontal.
horizontally. You can't use that, because I already admonished him once for using the name that was also in the title. The original horizontality says that when
Parallel. Wait, no.
that's getting close. When rock layers, I've switched fonts again, are deposited, they are. We say this phrase, this verbal phrase, laid down in flat, right, horizontal, flat, I'm trying to say horizontal layers. I guess we'll just say flat
You
layers.
just
I
say
guess.
ladder.
Yeah, we could, but that's the next one, which includes in this one, which is called lateral continuity. What's lateral mean? We've talked about this at least once. Yeah, lateral means referring to the side, right? The Latin word latos means
Lateral what?
latus? Lateral continuity.
Leg.
but it means relating to the side. So this one relates very closely to this because when the rock layers are deposited, they are laid down in, if we just have the word continuous to this, it means lateral continuity. Basically what this is saying is that if you see a layer of rocks, I'm going to do a different color here, orange. If you see a layer of rocks, hey, what's this top rock? Look at the back of your cheek. And then what's this bottom one? Top one is, say it again, sandstone. Bottom one is limestone. Okay, so if we have this, I was going to say sideways, if we have this angled layer of sandstone and limestone, and then we also see that it's got this, what's this one? This one's harder for me to draw.
Silt?
Yeah, we'll say this is siltstone. All of these, when they were laid down, were what?
Horizontal.
Oh, they were horizontal. So if these have been moved, they must have been,
Plate.
it doesn't have to be plate tectonics, but they must have been uplifted. They must have been uplifted. So there were 4 events here. Deposition of layer A, deposition of layer B, uplift, and deposition of layer C. Right? So in order they went A, B, then there was an uplift, and then C. How do we know that the uplift came before C?
Because C's not.
Because C is horizontal, right? That's what horizontality and lateral continuity means. More specifically for lateral continuity, if we see this kind of thing, what's this bottom rock? Oh, I didn't do a very good job of that. We'll pretend it's limestone. That was a terrible drawing of limestone. Sandstone. Lateral continuity says they must have been continuous. So where did this hole come from? What must have been the order here? A, B. What must have been the order?
A, B, and then.
And then the hole. A, B, and then erosion, probably, right? It might have been a crater from a meteor, but probably erosion. That's lateral continuity.
And that's because both of them are horizontal.
Right, exactly. So they were laterally continuous, and then they were, sometimes what we see is even this. Layer C can get deposited, should have done purple. This is supposed to be granite, or some other metamorphic rock. This really can't happen, but that's okay, it's pretty. This one would have happened after the erosion, right? And we can tell because it is laterally continuous.
Right.
Maybe it was a flood basalt. That would be nice because it could have been lava pouring over here. Don't say you, it's just lava. Okay, and then the last one, the last of Steno's principles, was I using Artelius or Expo?
Artelius.
Artelius. The last one is called Principle of Inclusions. This one, we're going to write, without using the word inclusions, we're going to write chunks.
What?
Chunks in a rock or layer of rock must be what? Relative to the rest of the rock, they must be, yeah, must be older. What's older, your chocolate chip cookies or your chocolate chips?
Well,
The chocolate chips, no, it doesn't depend. The chocolate chips had to exist before the chocolate chip cookie could exist, right? They had to.
Oh, I guess you're thinking that technical.
Chunks in a rock or a layer of rock must be older.
So then where's the chicken and the egg come from?
Oh, the egg. The egg.
Wait, why
There have been eggs for.
But when you
Almost.
eat chicken first,
Well, how did you?
Oh, no.
There were critters laying eggs before chickens ever existed.
Well, how? Okay, what came first? Was critters or the eggs?
There we go. That's a better question. What came first, the critter what lays eggs or the eggs? Yeah,
Well, they
good.
could have, like, over time, like,
Yeah, we know.
mammals could
Wouldn't the egg have to come first before the chicken?
Who cares? The what we do care about is that the chunks must
We
be
care about.
existing first before the rest of the rock. So anytime we have chunks in a rock, the chunks had to be there first. Do you have questions about Steno's principles?
No, you should erase the list to see which one's the best.
Okay, let's erase the board. I already can tell you which one's gonna. Just from the way they were writing. Ooh, that orange one erases fine. Uh-oh. Uh-oh.
Oh,
Uh-oh.
try erasing the other way.
Yeah. Oh.
So it's not the marker.
It's a Milagro.
Use a different eraser.
I think this eraser is actually fine. There are some of those are not as good because when one of them gets dead, I put it back in the pile of new ones, so then I never know whether it's going to be alive or dead. Yeah, the sideways erasing is the key here. I'm going to pause the video and tell you a joke that isn't supposed to be in the video. What? Okay. Okay, the last thing we're going to talk about today, we haven't quite gotten as far as I wanted to get, which is fine. We'll talk more about absolute age dating tomorrow.
Can you
But
erase uniformitism?
we still like that.
How can you erase it?
We still like it. I can, I will, but I'm not going to right now. Unconformities. Oops, let me make sure you correct it. Yes, unconformities. Let's do erase uniformitarianism actually because unconformities looks a little like it. I don't want you to get confused. Unconformities. There are three kinds of unconformity. Hey, don't do that. These are the three kinds of unconformity. These are going to be drawings.
Exactly the same.
Oh man, this takes me so long to write. Siltstone. Come on, Siltstone, be faster. What? Remind me what schist is. Is it squiggly lines? Like this kind of thing?
Schist.
Is that right?
Yeah, that's
Okay.
what it is. No, they're like this. They go like up to the corner.
Yeah, you're right. This will suffice. People would understand that I meant schist. Unconformities are places in the rock record where there's a missing layer. Maybe we date this layer of. Tell me what this is made out of.
It's silt, isn't it?
Yeah, siltstone. What's on top? Somehow we determine that there's a gap in geologic time here. Maybe we determine that this siltstone from elsewhere is, we'll say, Permian. That's an old dang siltstone. But we'll say the siltstone is Permian, and we'll say the sandstone is Neogene. We know there must be a gap in the rock record because the Permian doesn't come after the Neogene.
That's a big
right?
gap.
That's a big old gap. That's a big old gap, and this is called a disconformity. When it's, listen, what makes it a disconformity instead of the other ones is that this has to be sedimentary rock and sedimentary rock. This has to be sedimentary. It doesn't have to be sandstone, but it has to be sedimentary. If these are both sedimentary and there's a gap in the rock record between them, that's called a disconformity. Okay? This one is called, if they're both sedimentary rocks and there's a gap in the rock record between them, that's called a disconformity. Which one's older? BT dub?
The sandstone.
The sandstone's older, Tylee Underwood?
No,
On this one?
the
Yeah.
siltstone.
The siltstone. How do you know, Levi?
Because it's at the bottom.
It's on the bottom, right? It's unoverturned, it's on the bottom.
Oh, that's a siltstone. I messed up.
Okay, this one is called an angular unconformity. Why might it be called that?
Because it's at an angle.
There's an angle. Okay, we're going to go on to the next one. And the last one is called a nonconformity. Do they have to name them so confusingly? I guess. I mean, that's what they're called. So a nonconformity is like a disconformity, except, can you guess? Can you guess?
They're not sedimentary.
Yeah, the top one of them can be sedimentary. In this case, the sandstone is sedimentary, but the schist is metamorphic, and therefore not sedimentary. If one of them, or both of them, are not sedimentary, it's a nonconformity. So disconformity, both are sedimentary. Nonconformity, only one, or zero, is sedimentary. And in an angular unconformity, they're at an angle. This one takes precedence. If any of them are at an angle, we call it an angular unconformity.
Dope.
That's pretty cool.
Yeah, I would say that's dope. And also the last thing, you have a vocab word that says correlation. Correlation is just where we find fossils, and this is a vocab word, so I'm not going to run on the board, you should already know this. Correlation is where we find fossils or rocks that are in one location, and we find them in another location, and we can use them to date each other, right? So maybe we find a special kind of seashell in the Black Hills of South Dakota, and we find that same special seashell in New Mexico. We know, because of where that seashell is, that those rock layers are, if not the same age, then at least similar, okay? That's called what?
Correlation.
Correlation. Do you have it in your vocab?
Yeah.
Good.